Hello everyone, welcome back to another tutorial series. In today's tutorial, we will discuss about the math problem of analytical mechanics. Basically, we will discuss about the centroid determination of a composite body. So let's start. Here it is said that locate the centroid of the section of an angle iron of figure 1 whose dimensions are as shown in figure. So here you can see that there is an angle iron here in figure 1 and its dimensions are also given. Now we already know that if this is our reference x-axis and if this is our reference y-axis and if this is a rectangular area with length L and width B, the centroidal distance will be equal to L by 2 from the reference y-axis and B by 2 from the reference x-axis. Now using this concept, we will determine the centroid of this composite body. So for determining the centroid of this composite body, we will consider two rectangular portions. Here you can consider a rectangular portion as ABCD, which is marked as yellow color and named as A1. And you can consider another rectangular portion, which is ADEFG and marked as red color and named as A2. So we will consider this side from the y-axis as positive and this side from the x-axis, this downward side from the x-axis as positive. Now do some calculations. So first of all, we will calculate the area. So what will be the area A1? It will be equal to length into width, which is actually 7 into 1, 7 inch into 1 inch, and it will give a result of 7 inch square. Now, what will be the area A2? It will be equal to 1 inch into 6 inch, which will be equal to 6 inch square. Now, we have to calculate the centroidal distance of this two separate rectangular portion from the reference x and y axis. So, here it is our reference x axis and it is our reference y axis. And it is our rectangular area A1. So what will be the centroidal distance x1? The centroidal distance x1 will represent a distance from the reference y-axis, which will be equal to 1 inch plus half of its length, which is actually 7 by 2. So the final result will be equal to 4.5 inch. So why we have to add this 1 inch here? Because our reference y-axis is at a distance 1 inch from this edge of this rectangular area. So we have to calculate it like this. Now, what will be the centroidal distance y1? The centroidal distance y1 will be a distance from the reference x-axis and it will be equal to half of its width. The reference x-axis is at the edge of this rectangular area and the final centroidal distance y1 will be equal to 0.5 inch. Now calculate the centroidal distance x2 and y2 for the area A2. So here is our area A2, which is marked as red color, and here is our reference x-axis and y-axis, and these two axes are at the edge of this rectangular portion. So what will be the distance x2? It will be the centroidal distance from the y-axis and it will be equal to 1 by 2 inch, which is actually 0.5 inch. So why it is 1 by 2 inch? Because the length here is equal to 1 inch. So half of its length will be equal to 0.5 inch. Now, what will be the distance y2? Distance y2 will represent the centroidal distance from the x-axis. So here the width is 6 inch. So half of its width will be equal to 6 by 2 inch, which is actually equal to 3 inch. Now we have to finally calculate the centroidal distance for this composite body, which is represented as x bar and y bar. So we have to use the formula x bar equal to a1 x1 plus a2 x2 divided by a1 plus a2, and y bar equal to a1 y1 plus a2 y2 divided by a1 plus a2 for this particular composite body. So as we have already calculated the distance x1 y1 x2 y2 and a1 a2, we have to put the values here, and finally we will get the result x bar equal to 2.5 inch and y bar equal to 1.65 inch. So here x bar will represent the distance 2.65 inch from the reference y-axis in this side, and y bar, which is equal to 1.5 inch, will represent the distance from this reference x-axis. So finally, we have got our desired centroidal distance for this composite body, which is equal to 2.65 for x bar and 1.65 for y bar. So that's the procedure how we can calculate the centroidal distance for this particular composite body. Thank you, everyone.